ahead and we're going to jump in, and then Hugo asked if whoever made the Quizlets, if the link can be shared again in the chat. Okay.
What Quizlets?
In our last thing, I think it might have been Victor had, or I guess Darren, someone had made Quizlets just to kind of help with some of the terms and everything.
Hmm.
So that link should probably get shared soon. Someone has it. Okay, so on to chapter 2. This is where we start talking about our variables. And so a variable, it has an empirical measurement of a characteristic, or it is an empirical measurement of a characteristic. It always has one name and at least 2 values. So like an example, like, you know, say if you're on a political ID and you're just checking for it to be a variable, you're going to have like political party, and then at the very least, you're going to have Democrats and Republicans. And so that's just for it to be a variable, it's going to have its variable name, and then it's going to have at least 2 or more different values. And then, like we've gone over in class, variables differ in precision. And so our first one is our nominal level, which these are ones that they can't be ranked. They're like marital status is the main example. And one of the, so it deals with differences, but not quantities. And so like differences are like married, unmarried, or unmarried, divorced, never married, whatever. Like, so they're different, but it's not like on a scale, they're not ranked, there's no quantities involved. And so the easiest way that I found to remember this is that nominal means name. And that's all you're doing is you're stating the name of these different, the values are just the names describing the characteristic. Is there any questions on nominal?
Yes, me. So an example for a nominal variable would be gender.
Yes.
Okay, perfect. Thanks.
All right, so then the next one is ordinal level. And so this communicates relative differences. And so I highlighted and bolded relative because, so relative, you know, that means they are related. And so it's basically like, you know, on the scale, like, so these are the ones that will have the scale, they will be ranked. And so, you know, you're going to have different values that are relative to each other, related to each other. So like you have your kind of, you have your Democrats, your strong Democrats, your independents, your Republicans, your strong Republicans. Those are all related to each other because they're all about the political ID. And the numbers tell where they are on the scale relative to each other. So ordinals, I always like to remember order. So ordinals have order, orders can be ranked. And then the values can have a numeric code that reflects the relative amount of characteristic being surveyed. So like how I said, you know, with the very strong Democrat to very strong Republican, you can start at, you know, go 1 to 7. And you know, the lower the number is, the closer to 1 it is, that means it's more Democrat. The higher it is or closer to 7 it is, that's more Republican. And that's how you can tell the relative amount of the characteristic being surveyed based on the numeric code. Any questions on ordinal?
So how does this differ exactly? Like you said, marital status. You said you could be single, married, divorced, widowed. And here we have the example of strongly approve, strongly disagree, whatever. Like, how is that different? How do we know that that's an ordinal variable?
So because you can rank, you know, approve, somewhat approve, never approve, or, you know, because they're basically, all three of those are how much you approve. You approve a little bit, you approve not so much, you absolutely will never approve it. Whereas ordinals, or sorry, nominals are, you know, just saying what they are. It's like you are a Christian, you are a Catholic, you are an atheist, you are an agnostic. There's no way to really put those in
Yeah,
a
okay. I
rank
get it now.
order. Okay.
Thank you. Thank you.
Any other questions? All right, and then interval numbers, you know, that is the exact difference. So this is the example of age. You can tell exactly how much difference in age there is from one person to the next based on it. Any questions on that? So, and so now we're going to get into the central tendency, which is like your mode, your median, your mean. And so the mode is the variable that is the most common value of the variables, or it has the most, like, say you interviewed 1,000 people on their, you know, religious denomination, and 700 of those 1,000 people said they were Christian. Well, the mode would be Christian. That is the most common value of the variable. And so one other side point on this is that because nominal variables have nothing to do with quantities, you are unable to do median or mean on nominal variables. The only thing you can do is a mode. Does everyone understand that? All right. So the next one is the median. Now, so the median, this is the one where this is, so when you're starting to deal with numbers, whether it's ordinal or interval, but it's where, you know, if you have 100 cases, this is the number where 50 of the cases are below it and 50 of the cases are above it. It doesn't mean that it's exactly in the, you know, like right in the middle of the range of all the answers. It just means that of all the cases or occurrences, half of them are below, half of them are above. That's all the median is. And so for me, for remembering median, a median is in the middle of a freeway. You know, it's in the middle. You have half on either side. Are there any questions on median? All right, and then so mean is the average. And so this is where, you know, you're gonna take all of your answers, all your numeric answers, add them up, divide them by the number of answers you have to get the actual average. I don't think there's any questions on that. Everyone good? All right, so next we're gonna go into dispersion, which this is basically to which degree that the observations share the same values. So, you know, a tight dispersion is going to mean that, you know, most of the values were really close. But then if there's a much wider dispersion where they're kind of like all over the place, that means that there's a lot more deviation between the numbers. And so a lot of times you'll hear variance or standard deviation is probably the main one that you're going to hear. And then we'll go into that a little bit later. So once again, nominal variables, they can't be described by mean, median, or variance because they're not numeric values. Instead, you would use frequency tables, cross tabulations, or a bar chart. And so for frequencies, it basically has the little how to get the percentages right there, where you basically take the raw frequency divided by the total frequency. So that'd be like if you had 72 occurrences of this value out of 100, so then you would have 70 over 100 and multiply by 100 gives you your percentage. With ordinal variables, was there any questions about the cumulative percentages? Remember that was on the far side where it would basically, as it was going down, it was adding up. All right, I guess everyone is good with that. So that's the ordinal variables, and then a lot of your answers will be in percentiles, and you can use a lot of bar charts. When you get to the interval variables, that's when we get into skewness. And so skewness is considered the measure of symmetry. And so the more skewed it is, the less symmetrical. And so a positive skew is where the mean, which the mean is the average. So the average number in a distribution is higher than what the median is. And then a negative skew is when the mean is lower than what the median is. Does everyone understand that?
So a positive skew is when it's higher than the median?
Correct. So when you get this, like basically, so say right here's your median, you have 50 below and 50 above, but so the ones below it are all really close to the median, but the ones above the median go really high up. And so these have a higher numerical value. And so when you add all these up and divide by the number of occurrences, it's going to put your mean up here. And so that means that it's skewed positive above the median. Does that help? Does that make sense?
Kind of, yeah.
Okay. And then so for a negative skew, exact opposite, here's your median and you have all your ones above it really close, but then, the ones on the bottom go down further. And so when you add everything up and divide, your mean is going to be down here below the median.
And you get your mean by adding all the numbers up and dividing by how many numbers you added up.
Correct.
Right. Okay.
Okay, so now here's the next thing it goes on to is the standard deviation, which I don't think he's going to have us do this because he didn't talk about it in class a whole lot. But here are the steps, which is pretty much you calculate each value's deviation from the mean, then you square each deviation, sum the squares of the deviation, and divide the sums of the squares by number of deviations minus 1 to find the variance. Then you take this square root, and that equals a standard deviation. I just feel like that's way too much math. He didn't say we were going to be doing that much. He just said that we're going to, just have to do the simple addition and subtractions and like really simple math for the when we do the means comparison tables from chapter 5. So I would not stress over this. But yeah, that's how to do it. And then box plot is just talking about how it displays variable central tendencies. Box plots show its median rather than its mean. So you remember with box plot is you have the line to the bottom of the box, that's the lower 25. You have the bottom box to the middle line, and that middle line is your median. That is the second 25 percentile or quartile. Then you have to the top of the box, your third 25, and then you have the dotted line up to the mark, and that's your fourth quartile, your fourth 25%. And that's not so much about averages or anything. That's just saying like, you know, here's the bottom 25%, you know, and then the next ones are here. So, you know, the lowest 20, say you had 100 numbers, the lowest 25 numbers are going to be on that line to the bottom of the box, the next 25, next 25, and then the final 25. I think you all understand box plots. It's pretty simple, right? All right. Okay, so this was one thing that he said that you know, there was going to be a question on, and that was the bimodal distribution. And there's the frequency of distribution having two different values that are heavily populated. And so I think he said that it's probably going to be a bar graph where basically it'll have like a bunch of short bars going across, but in the middle on either side, it'll have two long, large bars. And so those large ones are two modes, making it bimodal. Are there any questions on bimodal versus unimodal?
So are both the long, tall ones going to be the same height or different heights?
They can be different heights.
But they're just going to be two big ones, so that'll, or two little ones that'll make it bimodal. And then when you have one mode or unimodal, it's just going to have one big peak.
Yep.
Okay.
Because with that, it's more about the number of occurrences and where the majority of those occurrences are. So then I talked a little bit about the additive indexes, how it's a summation of ordinary variables. Basically, they're coded identically so that you can kind of refer from one to another. Gives the example of the Lightheart scales, which are those like things that you always have to do where it says like completely disagree, somewhat agree, agree, you know, to strongly disagree, those like 7 values. I don't think there's going to be much on that because it doesn't sound like this quiz has a lot of questions. So I don't think that'll be one of the things he talks about at points. And then, so the next one is the density plot, which is, this was just the alternative histogram for visualizing distribution. And so instead of having like all the different bars, it was just like one line that went over. And so, yeah, it's just a smooth line of a histogram that shows dispersion. So it's not as concerned with like the exact numbers. It just kind of shows you, okay, that's the general idea of where the dispersion is. Is there any questions on that?
You think he's going to make us like identify like what kind of like a graph or a chart this is?
I wouldn't be surprised if he does ask, like, show, a histogram, a box plot. I think more likely he's going to ask if you have, this type of variable, what are you going to graph it as? So, and then he'll give you several answers. So like if it's a nominal variable, you know that it's not going to be a scatter plot. Because like it can't be any of the ones that, deal with the median or the mean. So it's not going to be a box plot either. And so that's why it's just like for nominal, it's only going to be like a bar chart or a histogram.
Okay, thank you.
Not a problem. Any other questions? This is the end of chapter 2. So I'm going to, if there are no other questions, I'm going to end and save the video from the recording real quick. And then everyone just same thing, just jump back in and then we'll start chapter 3 once I get the video downloaded. Alrighty then, I'll see you back in just a minute.